All right, we're going to start on page 253, but it's going to take me a minute to get to it, okay? Because I want to get you to have an intuitive idea of what corresponding triangles are, and then we'll get to the formal definition of corresponding triangles, all right? Now, we're familiar with the idea of corresponding angles. At least we should be from this kind of thing. Remember, we'd have two lines, mostly they were parallel lines, and a transversal, and then we'd say angle 1 and angle 2 are corresponding angles. And we would say that means they're in the same position with the transversal and their line, right? They're both above the transversal, to the left of their line, they're in the same position. We could also say that angle 7 and angle 8 are corresponding angles. They're in the same position. So when we talk about corresponding parts of triangles, or any geometric figure really, but we're going to stick with triangles for the most part today. When we talk about corresponding parts of triangles, we're talking about parts in the same position. Like this. This isn't in your book, so just look up here at the screen. These two triangles are going to have corresponding parts. Parts that are in the same position. Let's deal with angles first, because polygons have two types of parts. Angles and sides. Okay? So let's deal with the corresponding angles first. Angle A, right here. Bottom left of that triangle. What does it appear to correspond to in the other triangle? Angle X. They're in the same position, aren't they? So angle A and angle X are one pair of corresponding angles. Well, what does angle B appear to correspond to? So angle B and angle Y are another pair of corresponding angles. What's the last pair of corresponding angles? Angle C and angle Z. So we've got our three pairs of corresponding angles. Now, let's write our three pairs of corresponding sides. Tad more difficult, not much. Here's one side. We could call that segment AB. What side of the other triangle is in the same position as segment AB is? Segment XY. Well, another side of the triangle to the left is BC. So what corresponds to segment BC? Segment YZ. What's the only segment on the left I haven't talked about yet? Segment AC. Could I call it segment CA? Yeah. So what corresponds to segment AC? Segment XZ. Okay? So, do you think you understand the idea of corresponding parts? And I'll say parts a lot. There are two kinds of parts, angles and sides. So you got three pairs of corresponding angles, three pairs of corresponding sides, for a total of 6 pairs of corresponding parts. Now let's start working on the idea of congruent. Congruent figures, well, congruent segments, same size. And segments are all shaped like segments, aren't they? Congruent angles, same size. And angles are shaped like angles. Congruent figures have the same size and the same shape. Both things have to happen. Now look at these two triangles. Look at this one. I'm just going to pick this one up and put it over here. Don't those two triangles have the exact same size and the exact same shape? They do, right? So those are congruent triangles. And with congruent triangles, the corresponding parts, not only do you find corresponding parts, but the corresponding parts are actually congruent to each other. Okay? Since these two triangles are the exact same size and shape, look at angle A down here in the bottom left. Isn't it congruent to angle X? And angle B at the top, isn't it congruent to angle Y? And angle C is congruent to angle Z? And look, aren't the corresponding sides congruent? Segment AB is congruent to segment XY. Segment BC congruent to segment YZ. So, with corresponding, or excuse me, with congruent figures, the corresponding parts must be congruent. Does that make sense? Now, we can make this difficult if we want to. Here's how. Triangle ABC, and now you got more work to do to figure out what corresponds to what, don't you? So eventually that's not going to bother us. Okay? But you need to be aware of, we're going to do that. Heck, I can do that. Then I can flip it. Then I can rotate it. Then I'll flip it upside down. All right, so I can do all kinds of crazy things to it to try to confuse you about what corresponds to what. But are you with me on A to X, B and Y, C and Z, and all that? You with me? Okay. All right, so I'm trying to slowly get you towards the formal definition of congruent triangles. Still talking intuitive here. This is what I said a minute ago. If two geometric figures have exactly the same size and shape, they are congruent, or shape and size, the book says. They are congruent. So look here at the figures they call congruent. These little figures, I don't know what they are. They may be fish. I don't know, they kind of look like disembodied heads. Whatever they are, they're all the exact same shape and the exact same size, so they're congruent to each other. Figure 1 is congruent to figure 2, figure 2 is congruent to figure 3, figure 1 is congruent to figure 3, they're all congruent. Now look at the ones that are not congruent. 4 and 5 have the same shape, don't they? But they're not the same size. That's called similar. Similar figures have the same shape, different size. We'll spend a lot of time with similar triangles later on. Okay? And then number 6 looks to be about the same size as number 5. But see how that angle's not quite the same as that one? So they're not the same shape, are they? So, congruent, not congruent. You with me? All right, we are so close to having the formal definition, but not quite. Look here, look what I've done with triangle DEF. I copied it, and I put the letters on the inside because I want to be able to take triangle DEF and move it over here. It's actually congruent to that other triangle. But I'm going to have to move it around a little. Oh, come on. There we go. For you to see it. Because, see, at first, it's kind of hard to tell what corresponds to what, isn't it? So, I did this to make it a little easier on us. Since these two figures are congruent, that means their corresponding parts are congruent. So instead of just listing the corresponding parts, we're going to list them and we're going to state that they're congruent. For instance, angle D corresponds to and is congruent to angle T, isn't it? What's angle E correspond to? Angle R, they're congruent. What's angle F congruent to? Angle S. So the corresponding angles correspond, and since the triangles are congruent, the corresponding angles are congruent. Now let's do the sides. What's segment DE correspond to? Not angle TR, segment TR. What about EF? What segment EF? What's it congruent to? Segment RS. What have I not listed? DE? No, I mean DF. Segment DF then is congruent to segment TS. Okay? Now, here's the thing. We saw the congruent triangles. You guys' eyes open? We saw the congruent triangles. We concluded those 6 pairs of corresponding parts are congruent. What if it was the other way around? What if We saw that. We saw triangle DEF, and we saw those 6 pairs of corresponding parts congruent. What would we conclude about triangle TRS? That it's congruent to DEF, wouldn't we? Okay? Works either way. If you know the triangles are congruent, you conclude those 6 things. If you know those 6 things, you conclude the triangles are congruent. Now, believe it or not, this is about the most difficult thing we're going to do today, right here. Writing what's called a congruent statement. A congruent statement is saying one triangle is congruent to another. Name one triangle, whatever you want to name it. D, E, F. But that means there's only one correct answer or one correct name for naming the other triangle, because I got to match up the corresponding parts. I wrote down D first. What does D correspond to? T. So I got to write down T first. Since I wrote down E second, guess what I have to write down second? R. F last, S last. You with me? Now, I said there was only one correct name for that second triangle. That's because I had already named the first one. If I rename the first one and call it triangle DFE, let's make it even worse. Let's make it FDE. Guess what I have to do? I have to rename the second one. Because F doesn't correspond to T, what does F correspond to? S. So S has to come first. And D has to correspond to T and E with R. See how it works? Now look, some of you guys are drifting. Look up here at the screen. If I know this, I conclude this. If I know this first, then I conclude this. So it doesn't matter with which one you start with, they go together. 6 congruent parts means congruent triangles. Congruent triangles means 6 pairs of congruent parts. Okay? Are there any questions? All right, we've done the hard part. Now we're going to formalize it. On page 253, near the bottom, definition of congruent, let's make it triangles. 2 triangles are congruent if and only if their corresponding parts are congruent. That's what we just spent the last 10 minutes learning. If 2 triangles are congruent, then all 6 pairs of corresponding parts are congruent. If all 6 pairs of corresponding parts are congruent, then the 2 triangles are congruent. Questions? All right. Write this example down. It's not in your book. It's an example I want you to write down. We're given a congruent statement. Okay, so we're using the definition of congruence. We're given a congruent statement. Triangle RST is congruent to triangle XYZ. Now, 2 slides ago, we had 6 pairs of corresponding parts that were congruent, and then we wrote a congruent statement from it. Now, we're starting with this congruent statement, and we're going to come up with 6 pairs of corresponding parts that are congruent. Well, one of them, look, what's angle R? Just look at the way it's written. What's angle R congruent to? So that's your number 1. Angle R is congruent to angle X. What's angle S congruent to? And what's angle T congruent to? Piece of cake, right? Needs to be. All right, segments. What's segment RS congruent to? Segment ST, YZ, and segment RT. Piece of cake, right? Needs to be. Let's do some from today's assignment. So turn to page 256. Let's begin with number 1. All right, so we'll be using both of our learning targets here. We have to identify the congruent figures, and then we have to use the definition to write the correct parts. Oh, by the way, CPCTC, corresponding parts of congruent triangles are congruent. Get it? No, that's not what I meant to do. Corresponding parts of congruent triangles are congruent. That's what it all stands for. This book uses it. Most books use it. I usually write definition of congruent instead. They mean this because this book also says definition of congruent. Okay? So, whichever. Be familiar and be able to use both ways. Now, look at number 1 here, because number 1, it is kind of mean of them on the very first problem. They're trying to trick you. On number 1, we have this triangle here on the left. It is not just, you don't just slide it over to make the other triangle. See how it's labeled? Angle Y is congruent to angle S. This angle Z over here is congruent to this angle Z over here. So it's not a translation. I didn't just slide the triangle over. Instead, what did I do? I flipped it. Anybody remember what a flip is called? It's called a reflection. And let's see if I do. No. I'm trying to get it to let me reflect all that. But all right, so if I take this down here and I flip it over, it looks exactly the same. So you can't really tell that I did it, but I did. You saw me hit the flip button, right? So the moral of the story is make sure you match everything up the way it's supposed to be matched up. So angle Y is not congruent to angle Z. What's angle Y congruent to? Angle S. What's angle X congruent to? Angle R. Now, the book sometimes does this. They'll say angle Z, meaning the one on the left, is congruent to angle Z, meaning the one on the right. The book does it. I'll do it too. But isn't that just a bit confusing with the angle Z's? Because that's not the reflexive property, is it? I'm not saying angle Z is congruent to itself. I'm saying the angle Z over here is congruent to the angle Z over here. So a better way of writing that would actually be angle XZY is congruent to angle RZS. You could do subscripts. I guess the point I'm trying to make is I'd really rather differentiate between those, because otherwise you might think reflexive property instead of an angle Z from one triangle congruent to an angle Z from another, right? But the book does that some, so I'll let you do it because I don't want to fight the book on it. But I think, well, I know that's more clear. You okay either way? List the sides. What's segment XY congruent to? Look at the way it's marked. What's segment XY congruent to? RS. Again, look at the way it's marked. What's segment XZ congruent to? RZ. And again, look at the way it's marked. Segment YZ is congruent to segment SZ or ZS. Either way. Okay? The last thing we have to, so we've identified all the congruent corresponding parts. Now we have to write a congruent statement. That's where we say triangle. What do you want to name the one on the left? We've got Y, X, and Z to choose from. What order do you want to put them in? X, Y, Z. Seems logical, doesn't it? Congruent to triangle. Now, look what X corresponds to. So R has to come first, doesn't it? Then what comes next? And then last? That's called the congruent statement. Hopefully at that point you're stating the obvious. You know? All right, do number 2. Number 2 has 4 angles and 4 sides instead of 3. But it's just a translation, isn't it? I just take A, B, C, D and slide it over. It turns into E, F, G, H. So you don't have to worry about a flip, a reflection, nothing. So list the corresponding congruent parts, or the congruent corresponding parts. What's angle A congruent to? What's angle B congruent to? Angle C. Now let's pause for a moment. Could I have put angle B congruent to angle G? They're both right angles. Everybody look up here for a minute. Could I put angle B congruent to angle G? They're congruent, but are angle B and angle G corresponding? No. Okay? So we did it the right way. Yeah, F matches up with B, so I need to put F. Oops, didn't mean to erase it. There. And then angle D is congruent to angle H. Segment AB is congruent to segment EF. Segment BC is congruent to segment FG. Segment CD is congruent to segment. And segment AD or DA is congruent to segment HE or EH. Now, the congruent statement. We don't have a symbol for quadrilateral. We're never going to have a symbol for quadrilateral like we do with triangle. So you can just do this. You can just do ABCD is congruent to, and what do I have to name the other one? EFGH. All right, we good with 1 and 2? All right, so that's about as basic as those 2 learning targets can get, right? And those learning targets are basic. I mean, this is fairly basic stuff. All right. In the figure, triangle LMN is congruent to triangle QRS. Now, I'm not going to require you to do what I'm getting ready to do, but I need you to see it so that you can do this when you need to. By looking at the congruent statement, I know what's congruent to what, don't I? Angle L is congruent to angle Q. Angle M is congruent to angle R. Angle N is congruent to angle S. I also know what segments are congruent to each other. Segment LM is congruent to segment QR. MN is congruent to RS, leaving LN congruent to QS. Now, why might I ever need to do that? So I make sure I match up the congruent parts. Okay? Because look for number 4. We're supposed to find X. I see an X there. I see an X there. They're both in lengths of segments. Wouldn't it be nice if those segments were congruent? And they are, aren't they? Because they're corresponding sides, therefore they're congruent to each other. And if they're congruent, that means their measures are equal. Does that equation make sense to you? What does X equal? 20. Now let's find y for number 5. See y? Are those two angles congruent to each other? Yep. So what's that tell you about their measures? Don't everybody say it at once. They're equal. What does y equal? Sure does. It equals 50. All right. Let's turn back a page to 255 and look at the third angles theorem. This is really a corollary from the triangle angle sum theorem from yesterday. It's not a learning target, but it's something that can be really helpful. And it says if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. If two angles are congruent to two angles, then the third angles are congruent. Now, remember, the sum of A, B, and C is 180. The sum of angles J, K, and L is 180. So look, think about it. If those two are the same as those two, to get to 180, don't the two missing angles have to be the same measure? They have to. Okay? So if two angles of one triangle are congruent to two angles of another, the third angles are congruent. Look, let me put numbers on here. It'll make sense. If that's 70, that's 70. If that's 50, that's 50. Look at triangle ABC. Doesn't angle A have to be 60 to get a sum of 180? Look at the other triangle. Doesn't angle L have to be 60 to get a sum of 180? So weren't the third angles congruent? Yep. I'll bet you if I never pointed out to you that the reflexive property, symmetric property, and transitive property applied to congruent triangles, you would have assumed that they did. Doesn't it make sense that triangle ABC is congruent to triangle ABC? That's the reflexive property. If you write triangle ABC congruent to triangle EFG, doesn't that have to mean that triangle EFG is congruent to triangle ABC? That's the symmetric property. And if triangle 1 is congruent to triangle 2, and triangle 2 is congruent to triangle 3, doesn't triangle 1 have to be congruent to triangle 3? That's the transitive property. So like I said, if I'd have never pointed it out, you would have assumed they worked. I think you would have. All right. There's your assignment. Page 256, 1, 2, 4 through 12. Omit number 8 for now. 18, 37, 40, 41, and 44 through 50. All right.